quick recap what we have discussed yesterday so that, you know, because that is required. Let me open the Epic Pen. Okay. Okay. So when we were talking about, you know, when we were talking about the Docker yesterday, so we have discussed that Docker is a containerization tool, right? So what is the need of the container? Need of the container is that if the modern way of writing the code is the microservice kind of approach, where we are having one application, say banking, and banking needs internet banking, withdraw service, deposit, and customer care, right? So all these are implemented in the form of container. So these are loosely coupled. You develop separately. You means the development team, they develop it separately, and you invoke into your application. Okay, so banking is not adding the jar file of this. Instead of that, there is a URI or URL, you can say. So there will be some URL, right? So that URL, you are invoking it here. So that is the microservice approach. And in these kind of things, we prefer container, because if we are using the automation process by using DevOps, so we need these these things should be under the automation. Plus, these should be having a zero downtime. Zero downtime, how to achieve that we will see in the container orchestration. Okay. Now, also we have discussed that if you want to create a container, first you need a Docker image, right? So Docker image is nothing, but it is the one which is required to create a container. So when you create a container, in the container is mainly used for the application deployment. So your application is running inside the container, and container needs a Docker image, right? So for example, you want to deploy your Java-based application. Instead of installing Tomcat on your system and run it, what you can do, you can take the Tomcat Docker image. So there is a Docker image which is Tomcat on Docker Hub. So you can download from the Docker Hub. So this is my Docker Hub. You can go there and you can download the Tomcat Docker image, and then you can run it as a container. So Docker image is read-only. You cannot modify it once it is created. Docker image is set of instruction layer. So yesterday when I was deleting the Docker image, you have seen that there are many files get deleted. The reason is that because those are the encrypted layers which is in the Docker image. You cannot you know kind of it's not a file. Okay, it's not a file. So it is something which is collection of all these instructions, and jointly it is make one Docker image. Okay. Okay, for a developer point of view, that knowledge is enough that we are downloading the Docker image, but if you go in deeper level, then we need to know this how instruction layer works. That we will see in the Docker file. We will see how we can use the Docker file, and right, so those things we will see, right? So yesterday we run certain commands. We have used Docker pull and the Docker images. name. For example, Ubuntu is a Docker image. Okay. So what it will do, it will go to the Docker hub and download that image. So for that, we need the internet connection because this is cloud-based system. This is Docker hub. So Docker hub is a cloud-based repository of all the commonly used Docker images, right? So there are some images which are public. So public images, we can download it, you can download it, I can download it, my neighbor can download it, right? Anyone can download it. So there is no restriction. But if it is private, then only the authenticated users, those who have created or uploaded or have the access, so they can only access it. Okay. So far Ubuntu, Nginx, all these are the public Docker images. Few Docker images, a few things I want to discuss. Some images are there. One image is Tomcat image, right? So you can use similar way as you use the Tomcat on your machine. So this is Docker image, which is Tomcat. Second is Nginx. Nginx is a web server which is widely used. Okay, widely used. This is very important web server. So we are not going in deep of this, what is Nginx, but we will take it as a Docker image and we will deploy our application by using Nginx or maybe some basic. So I will be just taking it as a Docker image because it's a web server. Okay. S- So that we will be using in our examples. Third one is the Apache. Okay. Apache is again very popular web server and it has Docker image called HTTPD. Okay. And this is a again web server. So this Docker image also we will use very frequently in our examples. And fourth one is the OS related like Ubuntu, CentOS, right? So those are the Docker images also I will use. Now, one more thing I just want to point out here, which is related to the Windows Docker images. Okay? Windows Docker images. See, earlier, because I'm in the development more than 20 years, so I was a Microsoft application developer. So when I was developing the code for Windows-based application, so to implement this or to execute those uh, my code or my programs, so I need the Windows operating system. So there was a restriction if I develop the .NET based application, so that will run on the Windows machines only. It will not run on the Linux or other operating systems. But now it's almost 6 to 7 years now. Windows or Microsoft has realized, right, that that will not work because now it's a open source freeware, right? See, Java, it can run on all the platform. Python, you can run it on all the platforms, means Windows, Linux, Mac. So now Windows .NET, so they are having now their own .NET Core. So this .NET Core, now Microsoft has created this .NET Core, which can run on Linux, Windows, and Mac operating system. .NET is separate, .NET Core is separate. Okay? So it supports the Windows. You can implement this code on the Linux, Windows, Mac operating system. So you have heard about PowerShell. So PowerShell also now you can integrate with your Linux, Windows, or Mac operating system. So now Microsoft also, uh, you know, working on these platforms, so that if so now if you want to develop a Docker image, okay, so there is a Docker image, right, which is using the .NET Core application. So now what we can do, we can create a Linux based, see, if you see most of the, I would say almost 80% or more than that, images which are the Docker images, these are Linux based. Okay, some of them are Windows based also, but that is Windows Core. Windows Core is also CLI based, right? So .NET Core application, now you can deploy it on Linux, and Docker image we can create, means, for example, you are taking Ubuntu image and you will say, okay, I had developed a program in .NET Core, so I can deploy it inside the Ubuntu and I can create a Docker image. Okay, so now Windows based, not desktop based applications I'm talking about. These are microservices based, web application based. So those things also you can, in Windows, you can develop in .NET Core, and you can create your own Docker images. And there are some Docker images are also available. So these are the Docker images which we will be using in our examples. And I just wanted to, you know, discuss this particular Docker image which is related to the Windows. Is it clear, these 2 points?
Mm.
Okay. Now let us do one thing. Let us talk about now container. Image we have already seen. Image is read only. So when we say my Docker image is read only, then basically what is happening, that image is having the instruction layers, and those are read only. What is the instruction layer means? Instruction layer means, for example, whenever a Docker image is created, so it is having some file structure or file system. Okay, so if you are using Ubuntu or Linux based, right? So its file system is similar to that operating system. There will be root. Maybe there is no home directory. There will be a bin directory, root. There is a etc directory, root. There is a opt directory. Okay, and you can use the same commands which you are using in the Linux. So those commands we can use when we use this Docker image, but these are read only. You cannot modify it. Now, if it is read only, it means it is something, for example, if I say read this paper, but you cannot write on this paper. Now you say, oh, I see there is a change required. So in the change required, it means you need to cut some line, or maybe you need to add some line, or you need to modify something. So that we cannot do in the Docker image. That's why container comes into the picture. So container is the deployment unit. So if you are having an application and you want to deploy that application, how we were deploying so far? On virtual machines or on physical servers. So instead of that, for example, I have my internet banking application, and this is a jar file, and I want this jar file is to be deployed on a container, because it should be a deployment, right? So, but now I'm going to use container, and container needs a Docker image. So you need to check what is the suitable Docker image for that, right? For your container, if you want to run a internet banking application, consider it is developed in .NET Core. So you can say, okay, I will take my .NET Core Docker image. Now, Docker images are very customizable. Means people, they are creating Docker images as per their requirement, right? So container is a deployment unit. So you will deploy your code on the container, right? So let us create a container. So what I'll do, I will start my AWS, right? The one which we have created yesterday, that EC2 instance. Let me sign into that. Oh no, I have created the Azure, I believe. Portal.azure.com. Right. I'll go to my virtual machine. And I will start this machine. So it is getting started. Meanwhile, I will open my mobile exam. You guys are able to hear me?
Yes,
Yes,
yes.
sir. Yes, sir.
Okay, okay, okay. There was, looks like some disconnection. Okay, so my machine is in the started mode now. So I will use this one. I will clear the history minus C. Now what I'll do, first we'll talk about the containers. So containers are the deployment unit for the applications, and it needs a Docker image. So first we'll talk about first type of container, which is called the attached container. So as soon as you create a container, the control goes inside the container, and when we exit from the container is in the stopped mode. Okay, so let us see. So if I say Docker, all the container commands you can use run directly, or if you want to use the management commands, then means more explicitly you want to say that I want to create a container, so you can use the container run also. But container, that word is optional. So if I say Docker container run, and I'll say I want to go inside the container. Okay. So if I don't mention this inside the container, and I simply say Docker container run, and I will use the Docker image Ubuntu. And if this Docker image is not downloaded on your system, so that image should be there on your system. If it is not there, then it will download the image first and then create the container. So here what we are doing, we are creating the container, okay, creating the container, but uh, but it will execute and then stop. So now I have executed this Docker container run Ubuntu. Something happened. Let us see. So to see all the container, Docker ps -a command. So here you can see there is a container get created, which is in the exit mode. It got created 7 seconds ago. But then you might be thinking, what is the use of this? See, for example, you want to run a job, and that job code or script is written inside the Docker image. You want that script is to be executed. So there is something called command. Okay, so that we will discuss in the Docker file today. But you want that as soon as I run my container, that command should be executed and then stop. So in that case, you create a container without going inside the container. Okay, so this container is created, and this is the container ID. Every container is having a unique container ID, and it is using the Docker image Ubuntu, and it has executed this command, and it got created 10 seconds ago, but currently it is in the stop state, which is exited. And this is the some dummy name, random name is basically assigned to this because we have not given the name. Now, second case, I want to create the container, and then I want to go inside the container, attached container only. So I will say Docker container run -it, and then you can give the Docker image. I'll say Ubuntu. So Ubuntu is my Docker image. Now see, I'm inside the container. See, this is changed. Root add something, right? So this something is nothing, but this is the container ID. So there is a container get created, and that container is having this container ID. Now at this moment, I'm inside the container. Okay, so I'm inside the container. So if I say ls, so these are the Docker image files which is inside the container. Okay, so container is a write layer. Write layer means Docker image files are there, which is available for the container. Now, if you want, you can create a directory. If I say mkdir test, so test directory is created. If I say ls, so that test directory get created inside the container. Okay,
So
inside
why the
the
container ID is different? Like it is showing earlier, it is CEC
that was
to
a
now.
different container. That was a different container. This is a new container.
Okay, okay.
So that container got created and stopped. Now I'm creating new container with this command. So it has created one more container with new container ID. All right. And now I'm able to create a file or directory inside that.
And sir, suppose if we are trying to run same container again and again, like Ubuntu you started and then you stopped. Again you are starting this Ubuntu. So it is creating a new container or it is
Yes.
restart.
So whenever you run the container run command, so it always creates a new container.
What about
Okay.
the exist one, the stopped one?
That if you want to use, you can start it again, and we will see how to start. And then we can use that also. Okay, so stopped container can be started, and then we can go inside the container. All right. So now at this moment, I'm inside this container, and this container, I have this test directory inside that, which I have created, and I am able to create that test directory. Now, if you want to come out of this container, you need to run the exit command. So now I'm exited from the container. Okay. So I'm exited from the container. So if I say, now see the prompt also gets in. I'm back to my operating system, right? So, right. Now, the second type of container is called the detached container. These are mostly used. So, so these containers are running in the background. Okay. So here, see, when I was in this container, I cannot do other work, right? Until unless I exit from that container. So, but if you want something be asynchronous, then asynchronous means running in the background. So in that case, you can use the detached container. Let us try that one. So if I say Docker container run -IT. What is -IT? -IT is interactive terminal. See, when I created my first container, right, this container, so I used Docker container run and I did not use -IT. That is why I was not able to go inside the container, right? Now, in second command, I have used Docker container run -IT and the so -IT interactive terminal. So what it has done, it allows me to go inside the container and I can interact with the terminal. Okay, so -IT option is required if you want to go inside the container. If you don't want to, you just need to execute it, then this -IT option is not required. So this is a optional argument. Now Docker container run -IT and I will say -D option. So -D option indicates detach mode, means I want to create this container in the background. So for example, if I say I want to use Ubuntu Docker image, right? So now the container got created. So if I say Docker and ps minus a, we will discuss that command also. So you can see that this container is up and running. This container is not in the stopped mode because this is running. The other two were stopped because those are the attached containers and this is the detached container, right? So this container is up from last 11 seconds. So now container is running in the background. So see, whenever you install Docker, right? And if your Docker is not working, so there is systemctl. If you want to see Docker is running as a service, systemctl status Docker. So Docker is running as a service and it is active, right? Now, if I say um, uh, this command, right? So Docker ps minus a. So my Docker daemon, right? Docker daemon is my service. And it is handling all the requests which I am sending. Remember yesterday when I was talking about the Docker engine architecture, so I told you that there is a CLI. So this is my CLI when I am able to run the Docker command. Okay, so Docker CLI is sending this command to REST API, and REST API is sending to the Docker daemon, which is that service, and Docker service is sending me the response this through REST API, right? So this is how internally it works. Now there are three containers are there. One, this is in the detached mode, which is running in the background. And so Docker is a process. Actually, if you think about it, Docker is running as a service. So service is nothing but a process is running in my system. Okay. Docker, inside the Docker, we are having networking, other concepts, but that is related to that process only. Okay. So now three containers are there. So first container, this container is in the detached mode. These two are attached modes. So now we have discussed two things. One is attached container. Attached containers are those containers where you go inside the container directly, right? If you use -IT option, which is interactive terminal, means I can see the terminal of the container. If you don't use this -IT, right, and attached mode, then you cannot go inside the container. What is the use case? For example, there is a Docker image, some script is to run, and you don't want to go inside the container, then you don't use this -IT option. Second is the detached container. So the container which is running in the background. Okay, so it is running, it is doing its job. Okay, and and right, and it is not in the stop state. Now the thing is, this is container ID, which Docker image it is using. Command. This command get executed as soon as your container gets started. It got created. It is currently up. Ports we will discuss. And this is the name of the container. See, name of the container or the container ID you can use alternatively. For example, if you want to delete the container, you can use container means Docker RM this, or you can say container ID. So if we remembering the name is easy as compared to remembering the container ID. So that is why we will give some meaningful name. We can rename this. So let us uh, rename the container. So I will say Docker container rename, and I will use, I want to rename, you can use container ID or container name, and I want to call it as C1. Now if I say Docker uh, PS minus A, so you can see this container name is changed to C1. You can give any name, right? Same way, I want to change the container name uh, of second container, which is this one, to C2. And similarly, I want to rename the container, which is this one, to C3. Right? Guys, just 1 second. I'll come back. All right, I'm back. So, right. So we were talking about the renaming the container. So I have renamed all these containers. Now, if I say Docker PS minus A, so you can see now all the containers are renamed, right? Now, what I want to do, I want to means I want that this container is to be created during the creation time. It should have a name. So then you can say Docker container run minus IT. You can put this option name. So name of the container, say C3, C4, C1, C2, C3. Yeah. So C4 container. And I want to use a Docker image, say CentOS 7 image. So now what it will do, it will go to the Docker hub first and download this Docker image and then create the container. See, this image was not on my local system. So first it has downloaded that Docker image and then it has created the container, right? Now the container name will be C4. So if I say Docker PS minus A, so you can see there is a new container which is 8 seconds ago it got created. It is using the Docker image CentOS 7. This is the container ID which is unique. This command will be executed when the container get created and name of the container is C4, right? So if you create a container, then that container is having uh, that container is having the name now. Okay. Now let us discuss one more use case. Now containers are supposed to be lightweight. Okay, container should be lightweight. So you need to choose the appropriate Docker image, because whatever the Docker image you are using, so that is read only, and container is your having a write layer. Okay, container is having a write layer. Then read layer plus write layer, it becomes the size of the container. Okay, it becomes the size of the container. Now let us see with the example. Okay, size of the container. So size of the container is Docker image size plus write layer size. Write layer means whatever you are adding. For example, I have added a file which is 1 KB. So, and my Docker image size is 70 MB. Now the total size of container will be 70 MB plus 1 MB, for example, 71 MB, write layer. Okay, so if you want to modify something, that is through the write layer. Now, if I say Docker and images, so here you can see my Ubuntu latest image size is 78.1 MB, right? And we have created this container Docker ps minus a. So we have created this container, which is C2 and C3. So if I say Docker ps minus s, okay, so now here you can see um, this container, right? C2 and C3. Okay, so these are not showing because I did not use minus a. So I need to use minus a minus s. Right. Now here you can see the, let us take this example C3. So C3 is size is 0 byte and virtual size is 78.1 MB. What does it mean? It means that my Docker image, so this is virtual image. My Docker image size was what? 78.1 MB, right? So this is 78.1 MB, right? And there is a 0 byte for the write layer. Okay, there is a 0 byte for the write layer. So it means is total size of my Docker image is, sorry, container is 78.1 MB. Now here you can see this is CentOS 7, right? In CentOS 7, my total size is 204 MB, 204 MB, right? And I did not do anything, right? I did not create something in so my writable size is 0 byte. So total container size is 204 MB. Do you understand this? How we can container size means something which is, see, whenever your container is running on your operating system, it needs memory, CPU, etc., right? So So now when it is running, it needs 204 MB of space minimum. If it is running, for example, you are running 10 or 200, we'll take 200, 200 into 10 containers you are running. So it needs 2000, which is 2000 MB, means 2 GB of space. So you need to have that much space on your system, free space. Okay. So this is how we can find the size of the container. And this is important when you are working as a DevOps engineer, because you need to know that how much resources are required. Now, same way we can find or we can
So,
decide. Yeah.
so can you go to back command? This one, yeah. So why it is showing 22B size? in the
Or we have
Last.
created that test directory, right?
Okay, okay, MKDI.
So that is why it is 22 bytes. So basically what happens whenever you are, modifying any file or creating the new, so according to that size get created, required, right? So now my size will be 78 MB plus 22 byte, because 22 byte is not more, so it is giving 78.1 MB. If it is, for example, 10 MB, then it will be 88 MB. Cool. Now, let us talk about another thing, which is if I say Docker. Now, let us talk about one more thing. What I will do, I will pull a Docker pull Nginx Docker image, which is a web server. Right. Now, if I say Docker, if I create a container, Docker container run -it, name of the container, I will say web container. Okay. And I want to use the Docker image, which is Nginx. So Nginx by default, it runs at port number 8080. Okay. Now container get created. Now if I say Docker ps -a, so you can see there is a container which is running, and this is web container. And by default, it uses port number 80. Now it is up from last 5 seconds. Now I want to see its stats. Stats means statistics. How much memory it is using, how much CPU it is using, etc. So there is a command Docker stats and your container name. My container name is web. Now here you can see currently it is using 0% of CPU, right? So here if you see, it is using 0% of CPU. It is using 3.3 MB of RAM. Okay, this is the usage. This is my container is using. Okay, my container is using this much RAM. And what is the limit? This is the uh, free memory on host operating system. On my host operating system, its total capacity is 8 GB, and out of 8 GB, this much is free. So it means if this container can maximum use this much of memory, which is not a good idea. So what you are saying that this is my container, web container, and this web container can use maximum limit is it is currently using 3 MB, but it can maximum use whatever the free memory on my host operating system. So consider your container is start misbehaving. Misbehaving means some process which is running, and it is system out of memory. Something it is throwing the error, and it is in the infinite loop. So it will start using more memory, and it can affect the other processes also, because the maximum limit is the free memory of the host operating system. Okay, so it is something like that. For example, there is a person who goes to some hotel, or maybe something which is dharamshala, right? So so he goes to the dharamshala, and his dharamshala people says, okay, this room is for you, but other rooms are open. If your friend comes, you can use that one. So he is unnecessarily calling so many people, hey, you come, it is free of course. So now if new if the new people comes from the management side, they don't have the room because all are occupied. So same thing is here. This container can use this much. It doesn't mean that it has to use. So our container should have a limit. Now what that dharamshala people is saying, that okay, you do one thing, you you are restricted, you need to use only one room, you and other rooms are locked. So now that person can use only one room. So same way you will say I have container C1, so it will use only a specific memory. Not the limit should not be unlimited. So I'll say, so I can restrict my container to use the that specific amount of memory. Same way I can restrict to the specific amount of CPUs. Now CPU we will talk about. CPU unit is core, right? So you are having, for example, two core CPUs. So cores are further divided into millicores. Okay. So so this is, for example, 1000 millicore equals to uh, one core, or 1024 that millicores, that is represented with capital M. Okay. So same way with the this you see MIB. MIB means 1024. If only MB, it is 1000. Okay. Megabytes, gigabytes. So that is what we pronounce it. So if you somewhere MIB, it means 1024. If it is MB, it means 1000. Okay, that is the difference. Same way millicore. So if I want to use 400 millicores, okay, out of, if I have one core which is 1000 millicore, out of that I'm saying I'm using 400. Okay, so same way you can restrict your memory and CPU limit. Let us see how we can do that. So for that, first let me come out of that. You need to press Control C. Control C 2 times, 3 times. Okay. So now I have killed, or I have stopped that process. Now what I will do, I will create a container. So what I'm going to do now, create a container with limited memory and CPU. So I will say Docker container run -it. Name of the container I will say web1, and I will use -m for memory, or hyphen memory also you can write. And I will say I want to give 8 MB of memory. Okay, I want to give 8 MB of memory, not, this is the limit. So maximum it can use 8 MB of the limit, and I'm using the Docker image, say Nginx. Okay, so now if I say Docker, so there is one command. Let us see first stats. So Docker stat command. Now for web1, now you can see the maximum memory is 8 MB of memory, whereas in the previous web container it is 7 point, is whatever the free memory we are having. Now if this container is start misbehaving, it can maximum use 8 MB of memory, not more than that. Okay, so that is the difference. I hope you guys understand this, how we can restrict the limit. Now in Docker container, there is a command which is called docker inspect command, and your container name. So inspect command is basically used for the debugging the container. Debugging means, for example, you are having some issue, you want to troubleshoot. So with the inspect command, you can see all the properties which are related to that container. Now, if I run this, so here you can see all the properties are here, right? So you can see there are many properties. Uh, Here you can see the memory also. See, memory is 8 MB is assigned. Okay, you can run the grep command also. You can say Docker and container or Docker inspect. You can write container inspect also, your web1 container, and I want to grep, I want to find memory. Okay. So you can see here, I can see that total memory is assigned 8 MB of memory. Now, containers, you cannot modify it. Means once you assign the properties to the container, you cannot modify it, but you can update only the memory and CPU. For example, I want to I want to change the I want to change the memory 8 MB to 16 MB. Okay, to update the memory of the container from 8 MB to 16 MB. So what I will do, Docker container run not run, we need to update Docker container update, or you can run Docker update command, Docker container update, and I want to update my web1 container with the memory of 16 MB. Okay, so now the memory is updated. We can grab this. So now you can see the maximum limit is 16 MB. If I say Docker stats my web1 container, so you can see the web1 container is having maximum 16 MB, and currently it is using 3 MB, which is 20.85% of this total memory limit. Similar way, you can share the CPU also. So if I say Docker container run minus ID, name of the container, I will say web3, and I want to give the 400 millicores or 410 millicores. Mostly what we do, we take the percentage, right? But it is not the hard and fast rule. You can give any number, but it should be in that limit. So I want to give the 410 millicores to my Docker image in Nginx. 410, right? M is not required, right? So now if I say Docker inspect my container, which is web3, and if I grab CPU, so you can see the CPU share is 410 millicores. Okay, so this is how we can restrict the limit. Now, let us understand from the real-time point of view. So, yeah. So now consider you are having one microservice which is internet banking, right? So you are having this microservice, and you want this microservice is to be implemented as a container, and it is running on my web server, but it should not use more than 30% of the CPU. So for example, you are having 8 core CPU, right? And 30% is 2.4 core. So you will say it can maximum use 2.4 core CPUs. Okay. Same way for the memory. So you are having, say, an example, 24 MB of 24 GB memory, and you will say, okay, it can maximum use 10% of this, which is 2.4 2.4 GB, right? So that also we can now assign. Is this point clear? Memory and CPU, how we can restrict? This is the job
Yes.
of this is the job of the DevOps engineer, not the developer. If you are having a limit, you need to talk to the development machine developers, and you need to tell them that, okay, this is using a lot of memory and CPU. Please do some proper optimization. Is it clear, Manishika, to you?
Yes.
Nikhil?
Yes, sir, clear.
All right. Now, what we will do now, we will create one, we will see some operations related to the container. First of all, how to stop a container. Stop, start, restart, pause, and unpause, remove, and port forwarding. And okay, we'll see those all. So now if I say Docker, if I want to list all the containers, okay, list running containers. If you want to list the running containers, then Docker ps command. It will show only the running container. That exited containers you cannot see. Okay. Or you can run Docker this is the management command, Docker ls container ls command. So this will also gives the same result. So two commands exactly same. Okay, one way is that easy to read Docker container ls. This is from the beginning, Docker ps, when Docker was created since that time. Now I want to see the exited container also. So I'll say Docker uh, okay, list all the containers. So I'll say Docker ps minus a. Minus a means all. So now you can see all the containers. Or you can say Docker container ls minus a. It will also give the same output. So now you can see there are some exited containers and there are some containers which are in the running state. Now these two are my attached containers. So when you start any container, whether it is detached or attached container, it will be started in the detached mode only. So it means it will be running in the background. So consider this C3 container. If I say Docker start and C3, right? Now you can see, oh, something wrong. Docker, okay, because it was, we have used, we have not used minus IT. Let us start the C2 container. So if I say Docker and start C2, okay, now you can see C2 is in the, now you may have understand the importance of minus IT, because interactive terminal, I don't want to go inside the container when you are in the detached mode, right? So you have the option to go inside the container. So now you can see that C2 container, it is in the running state. Now it is a detached, right? Because attached is the one when you go inside the container immediately. Now I want to stop a container. For example, I want to stop this web container. So I will say Docker stop and web container. So now the container is stopped. So now you can see my web container is stopped 2 seconds ago. So stopping the container means whatever the application I am running inside the container, that is stopped. You cannot access that. Now I want to start this container. So I will say Docker and start web. So now it is started. Okay. If you want to restart, so restart means if the container is in the stop state, it will be started. If it is in the started state, then it will be first stopped and then start. So I will say Docker and restart. See, my web one is in the started state. So 11 minutes ago. So I will say Docker restart and uh, I'll say web one, Docker, sorry, web one So now if I say docker ps minus a, so you can see it is stopped and then restarted. Now it is saying 4 seconds ago it got started. Now there is another command which is pause. So pause command is basically not stopping your container. You means container will be in the halted mode. Means you paused it. If some processes are running, it will be in the pause state. And when you start, it will be starting from the same state where it was stopped, right? But in the stop, what it will do, it will shut down all the processes. And when you start, it starts from the beginning. So we can pause that. I'll say Docker and pause my Web3 container, for example. So it is not in the stop state. So if I say Docker ps minus a, so you can see it is in the paused state. Now, if I want to unpause or resume it, I will say Docker unpause and the Web3. Now it is unpaused, right? So this is 8 minutes ago when we stopped and started. At that time, it was saying that few seconds ago. So because it is not stopped. Now let us talk about another command, kill command, to stop the container forcefully. Okay, so if you want to stop the container forcefully, means for example, you are running one container and that container is in the this container is not getting stopped with the stop command because maybe some exception is causing some issues and you are not able to stop it with the stop command. You want to stop it forcefully, then kill command. For example, if I say docker kill and web container, so when you run this command, so container is there, right? But it is in the exit mode. Excuse me. Now it is having a number. This is called the exit code. If it is 0, it means your container is stopped in a normal way or shut down in a normal way. When it is 137, or there are some error code numbers, right? I will show you those error code number. 137 means if it is non-zero, it means your container is stopped in a abnormal way. There is something which is not doing well inside the container, and that stops the container. We use the kill command. Forcefully, we stop this. Right. So we'll see some, uh, some exit code, right, in Docker container. So you can see those exit codes. So if you see here, 0 for the successful, 1 for application error, 125 for Docker daemon error, 126 for command invoke error, and so on. 137 immediate termination. The container was forcefully terminated by the operating system. This is the kill command, right? Signal kill. Okay. So you can just walk through what are. So we have, if it is non-zero, it means it is not a normal shutdown in nutshell. Right. Now, next is that I want to go inside the container, to go inside the container. I want to go inside the container. So I will use docker exec command. Docker exec -it. I want an interactive terminal. I want to go inside my web container, for example. I will say web. Okay. And then I need to use a terminal which is bash. So now, uh, okay, web is not in the running state. So either we can start it or we will go into some other web. Now I'm inside the container. So now if you see the prompt, this is root at and this is the container ID, web1. So you see web1 container ID. Okay. So this is how we can go. Now I'm inside the container. I can run the ls command. I can create a directory, say my directory. Okay. ls, there is my directory. Now, if I exit, it will not stop the container because it is running in the detached mode. Now, if I go inside the container again, docker exec -it. Now I exited from the container. Now I am back to my operating system terminal. Now if I say docker exec -it and the same container web1. So one way I have told you that you can go by running the bash command, then you will be inside the container. But you want to execute the inside the container commands without going inside the container. So that we can run it from here directly. If I run docker exec -it web1 and ls, so it will go inside the container and then run the command. So I want to see, so see, I can see my directory command. So this command basically get executed inside the container. Same way, if I say I want to create a directory, mkdir uh, or test directory. And now here you can see there is a test directory. So you can execute the command without going inside the container. Okay. So, right. So this is how you can go inside the container. Now I want to remove a containers. I don't need that container for any reason. So we use docker, okay, rm command to remove the container and rm-f to remove the container forcefully. Now, if the container is in the stop state, you can remove it. So if I say docker ps-a, so you can see I have two containers, C3 and C4 and web, which are in the stop state. So if I say docker rm and C3, it will stop, it will remove the container. Container is removed. You can check docker ps-a. So you can see that C3 container is deleted. But if you want to delete C2 container, if I say docker rm C2, it will say I cannot delete this because some application is running. If something is running, it means you cannot uh, remove it. Someone is using that application. So it means first I need to stop this container and then remove it. But if you are sure that you need to delete this container, okay, so then what you can do, docker rm-f C2. Okay? Forcefully you can remove this container. Now container is deleted. We can double check docker ps-a. So you can see container is removed. If you want to delete, for example, you are doing some testing and you have created hundreds of containers. Now deleting one by one takes time and you want to delete all the containers. Now to delete all the containers, we can use docker rm-f. Forcefully, I want to remove all the container, $docker and ps-a-q. So what it will do, it will delete all the containers. So this command docker rm-, this is the input. rs, what is -q? -q is the quiet mode. What is quiet mode? It will return the container IDs. So quiet mode returns the container ID only. Okay, so here you can see docker rm-1 -f means remove forcefully all the containers and take the container IDs. Same way, if you want to delete the images, so if I say docker images, so I have these images. So same image is used for Nginx image is used for multiple containers, right? So if the image is in use with the container, you cannot delete it. So if I say docker now, I want to remove RMI, remove the image, which is CentOS and 7 image. You know, image is deleted. If you want to delete all the Docker images, then what you can do, Docker RMI minus F. Forcefully, I want, if some image is not getting deleted forcefully, right? Right, is not removed, is if I want to remove images forcefully, then minus F command I will use, and I will say dollar. See, let me. So I will say Docker images minus Q. So minus Q will return all the image IDs. Okay, same way Docker container PS minus A minus Q, it will return all the image IDs, all the container IDs. So I will say Docker RMI minus F dollar, and I'll say Docker images minus Q. So it will delete all the images. Let me share these commands with you first. Let me put it on the chat window. All right, so these are the commands. Just copy it from the not from that chat window. Any questions so far? If it is overwhelming, let me know. I will stop it there. Okay. If you think there are a lot of commands we need to revise, then you can stop me there. We will discuss tomorrow. No hurry.
Yes, sir.
We can continue.
Yeah.
Okay. Okay. Good. Now consider that we are having a we want to create a container. Now we'll take one example. We'll create a container. We will create our custom container. So what I'm going to do, I will create one container. Okay. In this container, I will use Ubuntu Docker image. Then I will install Apache server on top of that. And then I will have some file. Consider this development team, they had given me some file. I'm taking test.html, but it could be any complicated file. I want to copy inside my container. Apache is a web server, and it is having a special directory, which is where www and HTML directory. So this is a special directory where it hosts the files which you want. For example, test.html. So you can copy it here. It will be automatically get hosted. We will see this example, and we will access this file. So what I'm going to do, I'm going to create a container, Docker container run minus IT. Name of the container is, I will say, my web container. Okay. And I'm using minus P option, 80:80. What does it mean? Now, this is my host machine. And host machine, there is a networking for the Docker. So Docker is running in a private network mode. And my container, this web container, is created on top of this. So my host machine cannot access directly. Means, for example, this is a public IP address. This is my EC2 instance. This is public. I want to access this web container. I cannot access it with this public IP address. I can access with some network things, but by default I cannot access it. Now I want this web application should be accessible on the host level. Then I will use port forwarding. Okay, so I will use port forwarding. In port forwarding, what we do, we are saying my application, which is a web application, it is running at port number 80 inside the container. I want to map this container traffic with my host machine container. Now, host machine port number, which is port number 80. So it means whatever the traffic is running inside my container, I want to access through my host machine. So this port number can be any. It could be 84. I can put here. This is the host port number, and this is container. So I'm saying port 80 of my container is mapped to port 80 of my host machine. So it should not be in use. Here you can put 84. You can put 90, whatever. So this number can be changed. But this should be 80 because I'm going to use my application at port number 80 inside the container. So let us see this port forwarding. So port 80 of my host machine is mapped to port 80 of my container, and I'm using the Docker image, which is, say, Nginx. So Nginx, because I have deleted that one, that's why it is downloading first. So Nginx is a web server. So what I will do, I will take the public IP address of my machine. So if I go to my machine, this is public IP address, and I will go here. Now I should be able to access at port number 80. Right. So you can see I'm able to access Nginx web page. Okay. Now if I try to create one more time this, it will give the error. First error is that web container name is already in use. So see what is that container name web is already in use. So that is one error. Consider I will change this web error. So see what it is saying now. Unable to find, this is the troubleshooting step. Failed to set up the container networking driver, right? And here you can see port is already allocated, means which port? Host machine port 80 is already in use, not the container port. Because container is running in the isolated mode. And I want to access that port 80 to my, so if I put it here, say web2 container, right? And if I put it here 82, tell me whether this will work or not now.
So it will work.
Yes, because host has
Yes,
82
because
not a seven.
host, yes, because the host machine port number is now changed. Now it will work. Okay, so that docker ps minus a minus q command, right? So all the container, right? So that I wanted to show you port forwarding. Now we will create our own example. So what I will do, docker rm minus f dollar docker ps minus a minus q. So it will delete all the containers. Now I will say docker rmi. I want to remove Nginx image. I don't need it. So better to remove the things because it will be unnecessarily occupying some space on your system. So now what I will do, docker and container run minus id, name of the container, I will say web container because I have deleted all the containers. I'm doing port forwarding. Port 80 of my host machine is mapped with the port 80 of my container, and I'm using Docker image Ubuntu, right? So now that image is getting downloaded. Now if I say docker ps minus a, so here you can see port 80 is mapped to port 80. But at this moment, if I go here and if I refresh this, see Ubuntu does not have anything running at port number 18. So what I will do, I will install Apache inside my container. So I will go inside the container, docker exec -it, name of the container is web, and I want to install Apache. So apt update. So um, I'm updating this right now. Um, then so these commands I'm running inside the container. Okay, apt install Apache 2 is the package name. -y means if it asks the question yes or no, it will take yes. So now it is installing Apache on my web server or inside the container. Okay, now Apache is installed. Let me see. It is still giving that site not found. The reason is because service is not in the running state. So if I say same command and if I say inside the container service Apache 2 status, so it is not running. So let us start this service. Start. So it is started. Now if it is started, so you can see that I can access the web application which is running inside the container. So when you are using Apache, so every web server is having its own folder structure where it hosts the files. So if I talk about Apache, so there is a special directory which is called ls/var/www and HTML directory. So here this index.html file output is this one. Now let us verify that. So what I will do, I will create some different file. I'll say echo and h1. This is my web page /h1. So I'm creating very simple HTML file and I want to replace this into the file which is index.html. I will say index.html and this everything I'm doing inside the container. Uh, did I do anything wrong? Echo h1. I think because of these spaces. I think this command, echo command, we cannot run inside, means from outside. Inside the container, I'll go and then run it. Okay, so I will just go inside the container. So few commands we cannot run directly from outside. And here I will repeat this command. This command. Okay, now it is updated. Let me exit from here. And now if I say, if I go here now, it should be my page, right? So now this is confirmed that if I go and, if I go to this directory, index.html, if I put my file, if I place my file inside this folder, then it will be, my file will be hosted. Now consider your development team, they had given you the code. Okay, so what happened? Consider your development team. They had given you some code and they are saying, okay, deploy it as a container. So what you will do, you will take that code and you need to copy it inside your container, right? So it depends upon what web server you are using. So in the case of Apache, consider they had given a file test.html to you. I'm taking test.html, but it could be very complicated set of files. So what you need to do, you just need to put it under var and HTML directory, right? That's it. So let us do that. So what we will do now, we will create a very simple file on our host machine. I'm on my host machine. I will say echo and I'll say h1. This is my testing file. And I will put it into test.html. Right? So if I say ls, so I have test.html on my local machine. I want to copy this on my container. So there is a command docker cp command, docker copy command. I want to copy what? Test.html file, where I want to copy to my container. And my container name was web. And under that, which folder? Where www and HTML folder. I want to copy there. And copy is successful. We can verify with the ls command. So you can see, yes, now there is a test.html. That's it. In the Apache web server, you need to do this one. Now here, if I go and if I say slash test.html, so you can see this is my testing file. So now we have successfully deployed our application inside the container. Is this example clear to you?
So
Good,
Yes.
good. So this is, our daily life. That's what we are doing. We means if we are running our app, see there are many cases where you are running only containers or Docker with Docker Swarm, Docker Compose, but you know understanding fundamental is very much required. So please, whenever you practice, take every command from the beginning, right, and then go to the next step. So step by step, as I am teaching you, go in the same way. Okay. First, understand about the images, then container, how container can be stop, start, etc. Then how to deploy our application. Now, there is one more case. Now you have created this container. If I delete this container, that I will not be able to access that. No, containers cannot be shared. Containers cannot be shared. What does it mean? It means that if I have a container C1 and if I say, hey Raman, can you give me this container? I cannot give it to you because containers cannot be shared. Containers are a deployment unit, means it is running something. You cannot give this container to someone, right? But images can be shared. You can share the image. But my image was Ubuntu. And this image is a different image because it is having Apache. So many write layers it has. So what I want to do, I want to share this container. I need to convert this container into a image first. Convert this container into an image and then image you can share. This is the process to share. So this image is now my custom image because my image which I was having earlier, Ubuntu image, and this Ubuntu image here I have installed Apache and then it it has my test.html, this development image. So this container is having everything which is related to the development, right? So now I want to share with others, then I need to create a image from the container. So how to create the image from the container? So you can use Docker commit command, Docker commit, and your container name is what? Web container. And I want to create a image name is my web image. So I'm creating an image called web image. Now from the container, this image is having everything, whatever is inside the container. Now what I will do, I will remove the container. I will say Docker, after creating the image, I'm removing this container. Container is removed. Now I will not be able to access this page because container is removed. Application was actually running inside the container, right? So Now what I will do, I will create a container from this web image. So if I say Docker images, now there is a new image, web image. Its size is obviously it will be more because we have installed Apache, we have copied test.html and so many things. So we'll create a container from this web image. I will say Docker and container run -it. Name of the container is, you can give anything. Okay. I'm giving web again. I'm using port forwarding. Uh, name of the container. Name of the container is web, and I'm using port forwarding. I'm saying port 80 of my host machine is mapped with the port 80 of the container, and I'm using the Docker image, which is the web image. Okay, so now this container is created, but now this time the container is created with my web image, not the Ubuntu image, and web image is created from the container. I hope you are understanding what I'm saying, right? So now if I say Docker PS -a, so there is a container and there is a port forwarding also. Now tell me whether I will be able to access this page. Yes or no? No. Why no? Can you tell me why no? I have done whatever I mentioned, right? I have created a container image and then I'm running with that image. It should have Apache installed. It should have test.html. But why I'm not able to access it? Any clue? Any clue? Any idea?
In traffic,
Sorry,
just
Manishika, you have any idea why it is not running?
Um, can you show once again? Mm,
Everything is fine, right? Okay, let me tell you. So
okay.
here, yeah. So here what we have done, we have created the image from the container and image is read only. It means Apache is not running because image is read only. It will not allow to run anything. It's read only files. So it means Apache and everything is there. I'll show you that one. If I say Docker and exec -it, container name is web. If I say ls/var/web/html, so see everything is there, but service is not running. Why not running? Because it is a from the image. We have not mentioned that run the container, run the Apache server. So I will say now Docker exec -it web. And if I say service Apache 2 status, see it is not running because it was stopped because container in the container it was running, but when it has created the image and image is read only, that is why it is not running. Now what I will do, I will start and my web page should be accessible. Okay, start it. Now if I go back to my web page, see I'm able to access it. Do you understand this?
Yes.
it's clear.
Right? So image is read only. Container is having the right layer. So if you want to modify inside the image, you need to use the container. Now we have created our custom image. We can share this image with others also now, right? Because image can be shared, containers cannot. We'll stop it here. Okay, today we have run a lot of commands. So you guys need to practice this before coming to tomorrow's lecture. Tomorrow again, 7:30 to 9:30. Let me share these commands with you. So please revise these commands and I'll give you one assignment also. After executing these commands, you need to do that assignment. Okay. Let me share this on the chat window. These commands first. I will put that assignment into my GitHub repository also, but as of now, it is here. So you just need to go to this page. Okay, you need to go to this page, and at the bottom you will find one assignment. Okay, so please try to do this one, and also there is one more assignment. Spend more and more time with this, Docker. Love it, right? This is the industry demand. Industry, they are looking for DevOps engineer, those who are proficient in Docker and Kubernetes. Okay, so there is one more assignment here. So do these two assignments, and how you need to submit it. Either you can do one thing. Uh, you can send it to me directly, or maybe at the bottom, my students, they are basically writing in the comments. So you can just write your, uh, don't see these answers. Okay, before seeing this answer, you try to do this and put it into the comment. I will check it. Okay. Put your name on the top, Nikhil Manishika. I will
Mhm.
check it. Okay. So please do this, and we will meet tomorrow.
Thank you.
Thank you.
Thank you.
Thank you.